Welcome 6th grade. This is our third day with rocks. We talk about metamorphic rocks. Now, you'll notice the wavy look to many of these. We'll talk about why they have them. How are metamorphic rocks formed? If you remember from Monday, it's a change due to temperature, going up, and a change due to pressure. The change due to the hot watery fluids from temperature, and these pressures. It's almost like they're squeezing the liquid out of them. They cannot be because of sudden melting. If we melt and then cool, we get igneous rock. They cannot be from minerals, from solutions. If we do that, you haven't learned it yet, but we would get sedimentary rock. It is due to these three things at the top. Heat and pressure. When you heat things up, they're a lot more pliable. Rocks are the same way, and those pressures then make them move. Now, what can form a metamorphic rock? Do you remember the rock cycle? Any rock can form any other rock. So, metamorphic can become metamorphic. Sedimentary can become metamorphic. Igneous can become metamorphic. That happens due to temperatures going up and pressure increasing, and it causes the formation of the rock to change. So, any type of rock can change into any other type of rock. Igneous can go to metamorphic. Yes, heat and pressure. Something like, notice they're blue, granite changes to gneiss. Sedimentary, go to metamorphic. Yes, heat and pressure. Something like limestone can change to marble. That's the nice background we have today. And metamorphic can change to metamorphic. Yes, it can happen. Now, how do you classify metamorphic rocks? Remember, igneous was by where they cooled, and we could look at the mineral grains and the crystal types and all that. With these, we decide if they're foliated or non-foliated. One is going to have something that the other one doesn't have. That's the extent of it. Mineral grains flattened and line up in bands, foliated. Think of it like folding it. If you fold a sheet a bunch of times, oh, you've got that one side that shows all the folds. The foliated one, mineral grains flatten and line up in bands. So one on top of the other, on top of the other, on top of the other. We have those bands. All right, non-foliated. Mineral grains grow and rearrange due to the heat and pressure. Banding occurs, no banding. So you can see the bands of colors running through this rock. They line up, maybe not perfectly straight, but there are bands of color going through it. With the other one, no banding right there, because the heat and pressure, everything rearranges and turns into something new. Well, not something new, turns into a different form of that. So metamorphic rock concept map. We can go into foliated, banding occurs, grains flatten and line up. Non-foliated, no banding, grains grow and rearrange. This slide and the slide from the igneous rocks that were there, if you want to take a screenshot of them, they can be very helpful. It's all the information in one place. Foliated examples. So examples of foliated rocks. There's slate. There's gneiss. Slate looking like that. You can see the bands of colors running through there, depending on how good my video quality is. Gneiss, you can definitely see the bands of colors running through there. Note, they don't have to be straight. Non-foliated examples. Marble. Hey, you see it all in the background. Quartzite. Marble, you can see that it's here, there, and everywhere. All right? Quartzite, you can see that it may be speckled throughout, but there's no banding that occurs. That's everything we have for the metamorphic rocks. Hopefully I'll be making this your last hard copy worksheet you have to do. From here on out, after today, everything will be Google Forms. Don't forget, we have a meet and greet with questions and answers from people on Google Meet. Look at your Friday assignment sheets for that. It is optional, but you're more than welcome to come and ask questions, get that face-to-face look and feel.